Welcome to today's Explainer, where we're going to dive deep into the massive, invisible forces that literally shape our planet's oceans, weather, and ecosystems. You know, we usually look out at the ocean and just see waves crashing on a beach, but right beneath that surface is a dynamic, churning machine that keeps our entire world functioning.
So let's jump right in by pondering a pretty incredible question. What invisible force takes an astonishing 1,000 years to make a single journey across the globe, yet directly impacts the weather outside your window today? It's a journey that outlasts generations, and today we're going to track it.
Here is our agenda for today. We'll be looking at 1. The surface engine, 2. The deep conveyor, 3. The vertical elevator, 4. The ENSO disruption, 5. The seafloor foundation, and finally, 6. The climate future.
Section 1. The surface engine, wind, rotation, and rivers in the ocean.
Okay, starting in the top 400 meters of the ocean, we find our absolutely crucial first concept, and that is the gyre. The ocean doesn't just slosh around randomly. As global winds, like the trade winds and the westerlies, push the water, the Earth's rotation creates what's known as the Coriolis effect. This physically deflects the moving water. And when you combine that deflection with the solid boundaries of our continents, boom, you get these massive circular flowing systems.
What's really wild about this is how the Earth's rotation actually spins these 5 major water systems in entirely opposite directions. If you're in the North Atlantic or the North Pacific, the gyres spin clockwise. But the second you cross the equator into the southern hemisphere, they spin counterclockwise. And the structure is fascinating too. The currents on the western side of these ocean basins act completely differently than the ones on the eastern side. Western currents are narrow, they're deep, and they are fast, whereas the eastern currents are broad, shallow, and slow.
Now, the reason this matters to us is that these surface currents have a huge direct impact on how we live. Take the Gulf Stream, for example. It's a fast, narrow western current that carries warm water from the Gulf of Mexico all the way across the Atlantic Ocean toward Europe. This single current is actually the main reason why Western Europe has a surprisingly mild climate compared to places sitting at the exact same latitude over in North America.
Section 2. The deep conveyor, plunging into the abyss.
Let's move down into the pitch-black deep ocean. Down here, the wind can't reach, so this deep conveyor belt relies entirely on water density. We call this thermohaline circulation. It sounds complex, but it's beautifully simple. It's all about temperature and salt. Cold, highly saline water is heavy, so it sinks, while warmer, fresher water stays right near the surface.
So here is how this whole global conveyor belt actually fires up, step by step. It kickstarts way up in the North Atlantic near Greenland and Iceland. First, freezing polar winds cool the surface water. Second, sea ice forms. And here's a really cool fact. When ocean water freezes, it actually leaves its salt behind, which makes the surrounding liquid water incredibly salty. Third, this super cold, super salty water becomes so heavy, so dense, that it literally plunges to the ocean floor. Fourth, it spreads, creeping southward through the Atlantic, wrapping around Antarctica, and pushing into the Indian and Pacific Oceans. And finally, centuries later, it warms up, becomes lighter, and rises right back to the surface.
And get this, the time it takes to complete a single circuit is just mind-blowing. It takes roughly 1,000 years for water to make just one round trip on this global thermohaline conveyor belt.
Section 3. The vertical elevator, connecting the deep and the surface. You're probably wondering, how does all that deep, heavy water ever get back up to the surface? Well, the ocean has a sort of vertical elevator. First, let's look at upwelling. When prevailing winds push surface water away from coastlines, think off the coasts of Peru, California, or West Africa, deep water rises up to replace it. This cold, deep water is absolutely packed with nitrates and phosphates. It brings those life-giving nutrients up to the sunlight, fueling phytoplankton and creating literally the most productive fisheries on Earth. Then we have the opposite, downwelling. This is where surface water sinks, and it acts as a crucial delivery system, pushing vital dissolved oxygen from the atmosphere deep down into the dark ocean, where marine animals desperately need it to survive.
Section 4. The ENSO disruption, breaking the normal rules.
But what happens when those perfectly balanced normal surface winds just break down? Let's talk about El Niño first. Normally, strong trade winds push warm water west toward Australia, which allows all that nutrient-rich cold upwelling we just talked about to feed the fish in South America. But during an El Niño event, those trade winds weaken.
The warm water basically sloshes back eastward towards South America, the upwelling gets capped, fish populations completely crash, and global atmospheric patterns shift, causing severe floods in some parts of the world and brutal droughts in others. Then we have La Niña, which is the exact opposite extreme. The trade winds go into absolute overdrive, pushing even more warm water west and causing intense upwelling. This brings completely different weather, like much cooler and wetter conditions up to the Pacific Northwest.
Section 5. The Seafloor Foundation, Unveiling the Ocean Floor.
Okay, we've explored the mechanics of the moving water, but we have to talk about the solid ground underneath it all. Enter Marie Tharp, an incredibly brilliant geologist and cartographer working at Columbia University. For decades, the scientific community largely assumed the ocean floor was just a flat, featureless plain. Nothing to see there. But Tharp painstakingly spent years plotting thousands of points of sonar data collected by research ships, and in 1952, she mapped something extraordinary, a massive, undeniable rift valley running right down the center of the Mid-Atlantic Ridge.
Now, frustratingly, her groundbreaking discovery, which perfectly aligned with a very controversial idea at the time that the continents were drifting apart, was entirely dismissed. Her own colleague, Bruce Heezen, initially brushed off her meticulous, hard-earned data analysis as nothing more than mere girl talk.
But you know, the data doesn't lie. Tharp's map was proven absolutely correct by subsequent expeditions. Her work provided the most compelling visual evidence out there for seafloor spreading, and it formed the literal foundation for the modern theory of plate tectonics. Because of Marie Tharp, humanity finally understood that the ocean floor isn't flat. It's a dynamic, rugged landscape shaped by the exact same forces that build mountains and cause earthquakes right here on land. Section 6. The Climate Future, a Delicate Balance at Risk.
Finally, let's bring all these incredible mechanics back to the surface and connect them to a highly urgent global issue. Remember that 1,000-year deep conveyor belt we looked at? It relies entirely on ocean water getting super salty and super cold up in the North Atlantic so it can sink. But because of global warming, polar ice is melting rapidly. This is dumping massive amounts of fresh water right into the ocean, which drastically reduces the salinity. If the water isn't salty enough, it simply won't be dense enough to sink. This could severely weaken or even jam the ocean's massive thermal engine. In fact, if that circulation weakens, the source material notes a wild paradox. Europe could actually experience cooling even as the rest of the global average temperature rises. All because that vital warm Gulf Stream heat delivery gets disrupted.
Which leaves us with this final, critical thought to ponder. We've seen how perfectly balanced this invisible machine is, from the wind-driven gyres to the deep abyss and back up to our coastlines. If melting ice shuts down the ocean's conveyor belt, fundamentally altering the way heat, oxygen, and nutrients are distributed across our planet, what happens to our world? Think about that the next time you look out at the waves. Thank you for joining me on this explainer, and keep exploring.